You guys just said that, talked about the ratios, talked about which ones you thought. Okay, I'm going to relabel them. This is now 1. This is now 2. This is now 3. This is now 4. 2 of them work. Hands up. Fist up.
Okay.
Fist up. Everybody? Okay. Now put the numbers up. What do you think it is?
Wait, do you want like 2 different numbers or the same numbers?
Actually, wait.
Wait, 2 same numbers or 2 different numbers?
It's 2 different numbers.
50% chance?
2 different numbers.
I can't do that.
I can't do 2 different. Okay, I see a lot right. I see a little wrong. All right. So what is right is what's coming to 0.
Yes, sir.
The ones that approach 0. Because, and we'll talk about it now. So, this one, we can find the infinite sum, and this one, because they're approaching 0. All right. Guys, you need to hush now. All right. So, yesterday's equation was this. When we did a finite, why is it possible to do an infinite? This is 1 minus. Okay, this part right here, when we look at those rates and we take it to infinitely larger exponents. Hunter, if this rate is a fraction, let's say 1/2, as this exponent gets larger, this fraction gets smaller, doesn't it? And it gets smaller, and it gets smaller, and it gets smaller, and it gets smaller,
It's approaching
and
0.
it gets smaller because it's approaching 0. So eventually, this would basically have a value of 0.
Would it ever actually be 0?
No, but theoretically, it would approach 0. Okay? So, as this approaches 0, what is 1 plus 0? 1. And what is 1 times g sub 1?
1.
G sub 1. And that's where this formula comes from. And this formula only works in those 2 situations we looked at. It only works when the ratio, when the absolute value of the ratio is less than 1. So what does that mean? That means that ratio has to be somewhere between -1 and +1. And if it is, as this gets infinitely larger, this is basically 0. It approaches 0. And so that's where this formula comes from. The infinite sum formula. Okay, so let's look at these. We're going to do the top 3 together. You're going to do the bottom 3 on your own. The first one gives us the geometric sequence formula.
Is this yesterday's? I think you gave us
Yeah, it's the one you picked up yesterday. So go ahead and pull out those notes that you picked up yesterday that we did not get to. We're doing those today.
You scared me. I thought this was homework last night. I had no idea how to do it.
Magic. I didn't do any homework last night. I fell asleep on the golf course.
I fell asleep at 10 last week.
She don't believe me.
Okay,
I believe him.
so what is the ratio on this one?
My water. 7.
What is the ratio?
3 over 2.
Yeah,
Give me some knowledge, please.
3 over 2. And 3/2 is 1.5. Does this ratio fall within this interval?
What?
No, it does not. 1.5 is outside of that. So that means this one would look like this. And it would get infinitely larger forever, and we couldn't add them all up. So can we do this one?
No.
No.
Is that 1.5?
Yes.
Yes. And if it's in between -1 and
It's going to be on your quiz tomorrow.
That's no, it's just the homework quiz.
Notes and homework.
Okay.
Okay. What is the ratio? It looks like we're dividing by 3. Okay, so if we're dividing by 3, what would the ratio be? What would we multiply by? What's the reciprocal of 3?
3 over 1? 1/3?
1/3.
I thought 1/3 at first, but I thought I was.
Okay. Anytime you want to find the ratio of a geometric sequence, you can take any term and divide it by the term before it. So, 3 divided by 9 is 1/3. Or I could take this one. 1 divided by 3 is 1/3. So, anytime you're looking for the ratio, you can take any term and divide it by the one before it on a geometric series, and that will give you the ratio. Okay, so can we do it?
Yes.
Yes, because 1/3 falls in this interval. 1/3 would be between 0 and 1, wouldn't it?
Right.
Okay, so we can find the sum of an infinite geometric sequence. And what we do is we take the first term, which is 9, and divide it by 1 minus the ratio.
Is that the formula? Yeah.
All right, punch it in. Let's see what you get.
Here's my day 4. Absolutely no reason.
This is very last
That's why
night.
they
It's on the
call
wall.
it.
And I didn't put it over the other one.
You did? And did you put in the review that was missing?
That's-
Because
yeah,
my
that's
mom
what-
said.
I went in at lunch today. and
Oh,
did it.
okay.
Yeah.
Because it was before
Fourth
that.
period is my planning, so if you give me something in the 5th period, it usually takes till the next day.
Okay, that's fine.
8.666666667.
No one cares? About my invention?
Okay, you should have gotten 13.5. If you did not get 13.5, then we're having a punching it into our calculator issue.
Bingo
What's
bongo.
this? It is 7. Is that all we do?
That's all you do, bud.
I can't find day 6.
Hit it up a little smaller.
Go see if there's an extra one in the
Just
book.
Wait,
Wait,
never mind.
Down to the very end house. That's
Okay, is this geometric?
What?
Yeah, wait, yes.
Yes,
This is multiple.
because if we
No.
take 0.4 and divide by 40, it is the same as 0.004 divided by 0.4. It is 0.01. The
Wait.
ratio is 0.01. So if I take any term and divide it by the term before it, that should give me the common ratio. So I can do any of them and divide it by the one before it. And I should get the same thing if it's geometric to start with. Yes, ma'am.
I thought that geometric was if it's multiplying and dividing, and
Correct.
the other one is if it's
But-
adding or subtracting.
Okay, what I was just telling you is if you can't look at it and tell me the ratio, what you
Just
can do
divide by the
is
term before.
take any term
To find
and then
ratio-
divide by the term before it.
To find ratio on geometric, divide by term.
That is that's one way that always works. Take any term and divide by the term before.
And that's your ratio.
So what this actually looks like, if I was just giving correct mathematical notes, it would look like this. T sub n divided by T sub n minus 1.
T's. Okay.
So any term, divide by the term before it. That will give you the ratio. Okay. So the ratio for this one is 100. So you can find the sum. The sum is the first term, 1 minus the ratio. Now, this last answer was a terminating decimal. If it's a terminating decimal, you can write it as a decimal. But this one is not a terminating decimal. So when it is not terminating, what I would like you to do is leave your answer in exact form as a fraction. And if you don't know how to do that, when you divide this by this, you hit the math button, and then then it automatically goes to fraction. So you hit enter, enter. Enter, enter. And it should give you 4,000 over 99. And there's your nice little exact answer. We got it?
No.
But
Otherwise, it's a repeating decimal, right?
yeah, I know. But wouldn't you do like the number, like the whole number, and then something over 99?
Map, enter, enter.
Give me the ball now.
Like how many times does 99 go into 4,000?
Bingo bongo.
40.404040.
Yeah, so there's like 40 and then something over 99.
Oh, you could write it as a
I
mixed
got
number, that's
99
fine.
over 4,000.
I just leave it as an
It's
improper
4,000
fraction.
over 99.
Should be 4,000 over 99.
How'd you do the
Okay, now you try
So the reciprocal.
Go for it.
4, 5, and 6. You try 4, 5, and
That
6.
is-
And if you're not sure what you're doing,
How did they do the reciprocal?
I don't remember. I just totally deleted on my work.
He didn't actually get that.
hopefully I can get it back. Good job, making it go away.
Oh, we're doing the next one by ourselves?
How do you get it
The
back?
next 3.
Oh my gosh.
Wait on it.
If I can find my calculator.
It should have been easy.
Oh, bingo bongo.
No, it does not.
Do you think that's
6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 7.
okay? I'm on radio for the day.
You take any term and divide it by the one before.
I don't think this bad boy's gonna work.
Now with fractions, make sure you put them in parentheses or it'll give you not what you're looking for.
And divide it by the one before it?
Yep, take any term and divide it by the one before.
Wait. Don't
Divide.
tell us the answer yet, please. What's G1? First
Should be
check.
1/2. If I take this and divide it by that, it's 1/2. No, you don't have a calculator. That makes it a lot harder.
Over. I got
Wait, no, because it's a negative. It's gotta be greater than 1.
Yes.
There's a lot of 6s left in 7.
Okay, so you have to hit math, fraction, enter because it's not terminating.
Math.
That was my brain exploding. I'm confused.
I don't know where math.
2/3.
Enter. It's 2.
So if I have a, do I do this? Because it's less than,
Between, I rewrote it.
Positive.
It's between -1 and +1. You can do it.
okay,
And this is between those two.
okay.
I have to do the next one too. Cool, don't say the answer out loud, please.
Can we get this one? I
Hit me right here. I did.
I know. I thought I was gonna hit your eye. I was like, he's gonna have to blink. But I didn't.
I got
Because
the
I
answer.
moved to
What'd
the
you get?
chain.
Did you put do the thing yet? Math and
I tried to convince Phillips at the baseball game last night for next year's slogan to be
think we
"Get
do.
Some,"
I got -3 over 2.
because that's the baseball team's
It's the
motto.
same thing, but I don't think you should do that. It's like that.
Do you have to do math enter every time?
If you're switching it to a fraction, yes.
You have to switch to a fraction if it's -1.5.
Father is a
That's
hobby.
a terminating
I was at the
decimal.
mercy of Phillips.
Oh, so if it's like normal, you don't. Okay.
Correct.
Cool, I've never seen you wrong.
Okay, so this one, you should have gotten a ratio is 1/2 or 0.5, those are the same thing. So this does fall within this interval, so I can find a finite sum here. And it's the first term
sticky like 5, 6.
over 1 minus the ratio.
G1.
And this should give us 2/3. Okay? This one is a no for a couple of reasons. The main one is it's not geometric.
And it's
It's
negative.
not even geometric because this is -3 and that's +3. But let's say it was -3. Let's say I had actually put a negative right here and we said the ratio was -3. That's still a no because -3 does not fall within this acceptable interval.
So I
We
should
can
just stop
only calculate an infinite series if the ratio is between -1 and +1.
Oh, we got notified wrong.
Okay?
Yes,
Alright,
we did, because if it's not in between -1 and 1,
you can't do it. You just say
You
no
can't
and
do it.
move on.
So we didn't get it wrong, we just didn't put it in.
we weren't supposed to solve.
You got it wrong. It's 2 right.
How do we
Alright,
get it
this
wrong?
one.
It's just greater than, it's just greater, it's just less.
The ratio is
You might have to
negative
do it. You
1/2.
physically can't do the problem.
-0.5.
Question mark?
And -1/2
We did the
does
problem right,
fall
but we weren't supposed to.
in this interval.
Oh.
So,
Like if it's not in between the ratio right now and.
alright, you're about 3 seconds away from an email to your baseball coach. Yeah. Okay, so this one is 1 minus a -1/2, which makes a plus. And so this simplifies to -4/9. There was a hand raised.
Me.
Yes.
So 5, isn't it the final part? The final answer would be what you decide if it's
Okay,
negative?
5 is just, no, we can't do it. We cannot even plug into the formula. Because, first of all, it wasn't even geometric. So that's the main reason why it's no. Second, even if this was a -54, that would make the ratio -3, which does not fall in the interval, so we still can't do it. It's no. We can't even make something up.
We shouldn't have solved it.
Right. But like, you can solve it, right?
No. You cannot solve it.
But I did and I got an answer.
It just doesn't fit
But
the
it's
graph.
not right.
I know it's not right, but
Okay.
you can solve it.
Can you plug stuff
solved
into
it, right?
this formula?
Okay.
Yes. And it's wrong.
We'll say, but see, that's even less than -1. So
Yeah, but
is
then you
that
can
how
put
you
it
get
into the
answer?
graph and then you
So
can
I
press
guess
the
it's
table
a-
and then
Okay,
you get the answer.
a -3 is going to look like this graph. And that was a no. You picked this one because it was coming together. Ones that are going apart would be a no.
Right.
Okay, so that's why it's a no. Alright, now,
But we
this is the
solved
good part. Let's do some of these problems. Number 7.
Negative
A force is
4.
applied to a particle moving in a straight line in such a fashion that each second it moves 1/2 the distance of the preceding
So
second.
R equals 1/2.
So R is 1/2.
So
Beautiful.
we can do it because it fits.
Yay! Alright, now if the particle moves 20 centimeters in the first second, so we know the first one is 20,
G of 1 equals 20.
what is the distance that the particle can move? So we want every little piece of distance it can travel. All added up.
So just 20 over 1 minus 1/2.
Bingo!
Bongo. Bango.
Okay, so this is a word problem. And with word problems, we might need units. We have to use units if we're given units.
40
So this is centimeters, so this would be
centimeters.
centimeters.
Good job.
Okay?
I understand this.
Cool. Now, the next one we have to draw a picture for because it's a little interesting. First of all, we're dropping a super ball. That's one of those really bouncy balls. Bounce, bounce, bounce. All right? From a height of 5 feet, after each time it hits the ground, it bounces to 8/9 its original height. So what is R? 8/9. What is G sub 1? 5. Okay? So all that came from that first line. Okay, so I'm going to draw a picture of this. Here's my hand.
Why can't you just plug that
Okay.
in the calculator?
Oh.
Now, I am holding a bouncy ball, I'm going to drop this bouncy ball, and the bouncy ball is going to hit the floor. So there's my floor. So I'm going to take this ball and I'm going to drop it. Oh, that'll work. Let's put an arrow on the end of it. So it's going to drop. And then what's it going to do?
Go back up.
Go
It's
back.
going to bounce back
8/9
up.
Not as high as.
of
First
its
time.
original distance.
There we go, but I can't do it that way. That's too hard. Then it's going to bounce back up.
Okay,
8
good.
ninths. And then what's it going to do?
It's gonna go
Go
back
down
down.
again. And then it's going to go
8/9 up to its first.
up
I
again.
have
And then it's
a
going to go down
question.
again. And then it's going to go up again.
What goes up must
Then
come
it goes
down.
down again. Then it's going to go up again. Then it's going to go down again. Then it's going to go up again. Then it's going to go down again. And this problem says it's going to, we want to figure out how far this ball travels to its 6th bounce. So this would be my first. This would be the 2nd time. This would be the 3rd time. This would be the 4th time. This would be the 5th time. And this would be the 6th time the ball hits the ground, right? On its 6th bounce.
Okay.
So, this isn't a forever problem. This is a 6 times problem. So instead of using infinite, we have to go back to
Input the formula.
finite. Okay? So, the sum of the first 6 times is going to be g sub 1, which is 5, 1 minus r, which is 8 ninths,
Whoa, 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 whoa.
to the n over 1 minus r. Okay, so this was our finite formula. Remember, our finite formula is this. G s of n equals g sub 1, 1 minus r to the n over 1 minus r.
And we knew that because we didn't. Why? Why do we know that we have to use that formula?
Because we're only doing this one 6 times.
Okay, when there's.
It's not forever. It's not like this one. How long does it travel before it comes to rest?
Okay.
Yes, sir.
Can I just do 5 times 8 ninths 6 times?
No,
Why not?
because this distance isn't 8 ninths. It's 8 ninths the previous
Yeah,
distance.
you multiply 5 times 8 ninths and you get that answer. Then you
Okay,
multiply
you
that
do
by
it your way, and we'll do it the other way, and we'll see if we get the same thing. How's that?
Is that like? Do you not want me to do
I
that?
know she
No,
wants you to
go
try.
ahead. I want you to try it. Yeah, let's see if it works. Okay, so what this actually did was it calculated this distance, and 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 this distance. I counted all the downs. I counted all 6 of the downs. I didn't count the ups, did I? So what would I have to do to this to count this up and this up?
Double.
Double it.
Can you just multiply
Okay,
by 2?
so that's what I would do. I would multiply all of this. Whoops, I tried to go blue. Times 2. But I have a problem. That first down, did it have an up? No.
You subtract 5.
So you subtract 5 because the first down didn't have an up. This first drop didn't have a going back up paired with it. All right, punch it in. Let's see if you got 40.6
40.6.
feet is the total distance.
Which is right, Sam, so don't laugh at me.
I was laughing at you, Cole. Mitch had a funny joke.
No. I was right.
Thanks for giving me credit.
Okay, now this one, very similar,
Got it?
except
He didn't.
we're not, is that what you got, bud?
I got 40.7.
So close.
Wait, would that be wrong?
Yeah. Okay. So, the next one is before it comes to rest. So it's the same idea, except we're doing the ball as many times as it bounces.
No. It's a bird.
But it still only counts the downs. So even if we do it this way, we would need to double that and then subtract out the initial. Because we're missing the up.
Miss
We gotta put this
Miss
part down.
Willoughby, you got a bird trying to break through your window.
I know, that's Millie.
Melly?
You named it?
Millie, we named it because after stars Mill. That's
Can we
Millie.
rename it?
It's our class pet.
I have a bird that comes to my house every summer.
That's cool.
One day I woke up and
Alright.
there was a
Starts
dead
going.
bird that hit my window. It was just trying to get me.
One time I ran over a bunny rabbit.
Please.
That wasn't funny.
But that was pretty
Okay,
gnarly.
and here we should get 85 feet.
They have taps on them.
Did you?
Only a second.
Good job.
Please engage. Stay engaged.
Oh, I tried it for
married
so
it?
long. I can't
That's the geometric.
This is geometric infinite.
Come on,
I got a cut right here. I keep yawning and it hurts.
This is geometric but finite because we only did 6 bounces.
Gotcha. That's
Here it
infinite.
bounces till it's done.
Gotcha.
Alright, so this last one is the same idea.
Please.
Alright,
Oh.
except this time we're dropping a basketball off a wall. So there's my basketball. Here's my 10-foot wall. Okay. Now, it doesn't actually state the ratio, but it says the first drop is 10. Then it only comes back up to 8. Then it only comes back up to 6.4. So, if that is our geometric
ratio.
sequence, we have to find the ratio. So to find the ratio, I said you could take any term and divide it by the one before it. So I could take 8 and divide by 10, or 6.4 and divide by 8. No matter what I do, I get 0.8 is the ratio. It better be a common ratio. I better get the same thing every time or it's not geometric.
Yeah, but if you do 6.4 divided by 8.
Do it. I'm right. Punch in 6.4 divided by 8 on your
I
calculator
believe you.
and be amazed.
6.4 divided by 8 is what?
0.8.
What?
Yo! Oh yeah, because 8 times 0.8
Yeah,
would be
that makes sense,
6.4.
actually.
Why is that such a big deal?
Good.
Because what is 8 times 8?
Alright, so now we know
Oh,
R.
yo.
Now we know these 1. You try number 9 now. It is just like 8B.
What's the next song?
Well,
Okay, y'all have to be quiet. Because I'm to the point where I'm about to lose it. I'm on the verge of becoming the wildebeest.
So this is the geometric. Is it infinite?
Yep. When it says, that tells me we're looking at that infinite.
where'd we get the times 2 from?
Because that gives me the up and the down.
Oh yeah.
Oh, yeah.
And then I have to subtract out 10 because on the first one, it didn't go up and down. It just went down.
Down.
Are we gonna do a lot of bouncing?
So that really bothers me, my emails you have.
Oh my goodness, this bird. I just want
That
to
would
see
bother
it.
my husband also. I get like 30 something a day, and it's just really hard.
I just
That's
go
cool
through,
and
like,
popular.
this month and
Can't
just
you
read,
mark
like,
all as
everything.
red? You can click
Can we
that.
check this bird out, please?
But then she wouldn't know like what's actually important.
I
That she
feel like
needs
it's
to
gonna
read.
hurt itself.
I bet.
I don't know.
All right, did you get 90?
Yes.
Okay, make sure you have this note sheet tomorrow with the rest of your note sheet
Is the back.
and your homework, your corrected homework. Now, the other thing is, the last part about the quiz, and I'm not sure if I told you this yesterday, you have to have your name written in ink at the top of all your pages. Hayes, can you tell me why we're doing that?
So you don't get other people's work.
Yeah. So you don't
Okay.
go to somebody in my third period and ask for their notes and think you get to use them. That would be cheating.
Can we just have
Oh, that's a good idea.
Can we just
Except
have
I blew it for you, sorry.
this name?
No, like I don't